We need to solve the following linear inequality. So we'll begin by rewriting our given linear inequality as 1 over x minus 1 minus 2 less than equals to 0. Right. Now what we'll do, we'll combine the two terms on the left hand side. So here we have x minus 1 in the denominator, and in the numerator we have 1 minus 2 times x minus 1. So this value is less than or equals to 0. Solving the numerator, we have 1 minus 2x plus 2 divided by x minus 1, which is less than or equals to 0. And this gives us 3 minus 2x divided by x minus 1 less than or equals to 0. Now what we'll do, we have 3 minus 2x. That means the coefficient of x is a negative number. We'll try to make it positive. In order to do that, all we have to do is multiply it with negative 1. However, we have to be a little bit careful here. We'll use a property of inequality. That means, let's say if we have a number a which is less than or equals to b, and we have another number c which is a negative number, that c is less than 0. Now if we multiply a with c and b with c, in doing so the inequality changes. That means ac will become greater than or equals to bc. So that means we will have 2x minus 3. We have multiplied the numerator 3 minus 2x with negative 1 divided by x minus 1. Here we have not multiplied anything to the denominator because the coefficient of x is simply positive, so that's fine. This will become greater than or equals to 0 since we have multiplied with a negative number. Now we need to solve this particular linear inequality. Solving this linear inequality is the same as solving the original given linear inequality. Now this follows that we will have two cases, case number 1 and case number 2. So here we are given a rational expression 2x minus 3 divided by x minus 1. So this is greater than or equals to 0. So this would mean two things. When both of them are positive numbers, then a positive number divided by positive number makes them greater than 0. So that means we have 2x minus 3. This will be greater than or equals to 0, and simultaneously x minus 1 is greater than 0. This will not be equals to 0. That's because if we take x minus 1 to be equals to 0, we'll have division by 0, which is not allowed. And in case number 2, when both of them are negative, that means we have 2x minus 3 is less than or equals to 0, and simultaneously x minus 1 is also a negative number. Here again, we're using the same logic that the denominator cannot be 0. Now we have negative divided by negative. That will make this particular linear inequality valid. Now let's try to solve each of the two cases independently. So we'll have 2x is greater than or equals to 3 and x is greater than 1. Now we'll divide both sides with 2. Now since 2 is a positive number, what will happen? This is not going to change the sign of the inequality. So we'll have x greater than or equals to 3 over 2. And we have x greater than 1. What we'll do, we'll try to find a common solution. So here we have to draw a number line, and on the number line we'll take 0, then number 1 and 3 over 2, which is 1.5. That will be greater than 1. So let's take 3 over 2 to the right of the 1. Now it's given here that x will take all the values which is greater than or equals to 3 over 2. So we'll have all the values of x which is greater than 3 over 2. That means all the solution of x is going to lie to the right side of 3 over 2. It will start from 3 over 2 and go all the way up to positive infinity. And the second one is saying that we have to consider the values of x which is greater than 1. So here 1 is not included, but we'll take all the values of 1 which is greater than 1. Now what will be a common value of x which satisfies both the two conditions, that x is greater than 3 over 2 and x is greater than 1. So this is going to be the common region, and this common region is nothing but x is greater than or equals to 3 over 2. So here we have x greater than or equals to 3 over 2. Next, let's come to case number 2. So here we'll have 2x is less than or equals to 3 and x is less than 1. So we'll divide both sides with positive 2. That will not affect the sign of the inequality. So we'll have x is less than 3 over 2 and x is less than 1. So we will draw a number line. On the number line we will have 0, 1 and 3 over 2. Here we are having the condition the x will take all the values which is less than or equals to 3 over 2. So that means the solution of x is going to be to the left hand side of 3 over 2. And we have x is less than 1. So x is less than 1 means where x equals to 1 is not included. All the values of x which lies to the left side of x equals to 1. Now there we need to find out the common solution of x which satisfies both these two inequalities. So this is going to be this common region. So this common region means we have to consider the values of x which is less than 1. Will not include 1. 1 is not a part of the solution. Now let's combine these two solutions. So what we have is a number line. On the number line we have 0, 1 and 3 over 2. So the first, from case number 1, the common solution is that we have to consider all the values of x which is greater than 3 over 2. That means it's going to lie to the right of 3 over 2. And case number 2 tells us that we have to consider all the values of x which lies to the left of 1. That means less than 1. 1 is not included. So we have a value. Now we will write it in the interval form, which is also referred to as the solution set. So from the number line we can say that x will take the value from negative infinity to positive 1. So this is going to be an open interval. That's because 1 is not included, not a part of the solution, and negative infinity is unbounded. And we will also have to consider, so we'll take union to consider 3 over 2 going all the way up to positive infinity. So here we have used the closed interval to denote 3 over 2, which tells us that 3 over 2 is a part of the solution, and infinity, that being unbounded, we have used an open interval. So this is the solution to our given linear inequality.